Now I'm going to be teaching you how to name compounds with polyatomic ions. And on the back of your rule sheet, you will see that there is a polyatomic ions chart here. And that has some of the common polyatomic ions. It has their names and also their formulas and their oxidation numbers. Now this oxidation number, say for ammonium, this +1 is for NH4 together. And the way that we usually write polyatomic ions is I try to always put them in parentheses so that you know they're a package deal. Now, you might remember from class that I used the example of Lucky Charms. Like, what would Lucky Charms be without the marshmallows in the cereal? And the kids were like, it wouldn't even be Lucky Charms. Well, if you didn't have 1 nitrogen and 4 hydrogens in this ammonium, it would be something else. So you don't mess with what's in the parentheses. You don't mess with ammonium or any other polyatomic ion. When it is a polyatomic ion, you don't split it apart or mess with it. Now, with a polyatomic ion, NH4 for ammonium, that means there is 1 ammonium ion right now. If I were to put a number on the outside of this parenthesis, say a 2, that would mean there are 2 ammoniums right here. So if there's more than 1, that number will be on the outside of the parentheses. Now we're not going to be distributing this number to each of the elements in the parentheses. This applies to the polyatomic ion as a whole, so there are 2 ammoniums in this situation right here. Okay, so what we're going to do, I'm going to take you through 4 different problems that have polyatomic ions, and we're going to start on the front side of your rule sheet, just like we usually do. We're going to start with the rules, and we're going to count the number of elements. So with this first one, NaNO3, we're going to count how many different elements we have. We have Na, we have N, and we have O. So we have 3 total elements. Step 2 says if there are more than 2 elements, well, there are. So we're going to follow the rules of compounds with polyatomic ions. So we're going to flip over the rule sheet to the back. And if you'll notice, there are 3 types of polyatomic ion compounds. Oh, sorry, that froze. It freaked me out. So there's metal to polyatomic ion. So that would be the metal would come first and then a polyatomic ion. Then there's polyatomic ion to nonmetal. So that would be where there was a polyatomic ion at the beginning of the compound followed by a nonmetal. And then there's polyatomic ion to polyatomic ion. So there's more than 1 polyatomic ion in the compound. There's one right after the other. In this case, we have a metal first and then our polyatomic ion. So we're going to follow these rules up here. Now, if you notice, this does have the asterisk, and it says if the metal has more than 1 oxidation number, see directions on front of rule sheet. That is for the metals that have more than 1 oxidation numbers that you can see on the periodic table. Any of these are all metals that have more than 1 oxidation number, so we need to do Roman numerals. Sodium's not one of those, so we're not going to worry about that. All we have to do is name our metal first, which is sodium, and then we have to name the polyatomic ion, which if you look down here, NO3 is nitrate. So I'm going to write sodium nitrate, and I am done. So it's very simple, very straightforward. Now the next example I'm going to take you through is a little different. It's NH4Cl. So the first step, for the rules, I need to count how many elements. I have N, H, and Cl, so I have 3. The second step says follow the the compounds with polyatomic ions rule. So I'm going to look here and see, what do I start with? Do I start with a metal or a polyatomic ion? I pick ion. And right now, at the beginning, I try to always get these in parentheses so that you recognize them right away. But by the end of our chemistry unit, you will most likely be able to see this in a compound, and right away you'll be like, oh, that's a polyatomic ion. So you'll get pretty used to seeing them. So we have NH4 here. It starts with a polyatomic ion, but does it go to a nonmetal or another polyatomic ion? It goes to a nonmetal. So I'm going to follow these rules. So I'm going to name my polyatomic ion first, which is ammonium. And then I'm going to change the nonmetal to have an IDE ending with just the first syllable, so chloride. And I'm done with that one. Now the next one, let me fold my paper here. It's getting more and more crooked, excuse me. There we go. So the first step is counting the number of elements. So we have N, H, S, and O, so that's 4 different elements. Step 2 says if there are more than 2 elements, there are. So I'm going to follow these rules on the back. I start with a polyatomic ion, so I know I'm dealing with one of these two. And then I have a second polyatomic ion, so I know that I'm dealing with this third kind, polyatomic ion to polyatomic ion. This is, I think, the easiest one. You just name the first polyatomic ion, ammonium, and then the second, sulfate, and you are good to go. Now some kids get a little stuck because they say, well, what about this subscript? What do I need to do with this? The subscripts only come into play if you have to do Roman numerals. And we haven't had to do that yet, but you're actually going to do that for this next question. So I'm going to count the number O, so that's 3. And then my second step is to flip over to here. So I start with a metal, so I'm going to name my metal first. It's copper. But copper is one of our metals that has more than one possible oxidation number, so I have to use math for this one. So I need to determine how many sulfates I have here. Pretty much every time I go through this in class the first time, I ask the kids, how many sulfates do I have? And 90% of the kids say, well, you have 4 because of this 4. No, I do not. I have 1 sulfate because sulfate is SO4. So I only have 1 sulfate here. If I had more than 1, there would be a number on the outside here. So I only have 1 sulfate, so I'm going to do 1 times, and then look back down here. Sulfate has an oxidation number of 2-. So I've got -2 coming from sulfate. I need +2 coming from copper in order to balance this compound. So how many coppers do I have here? I don't have a subscript down here, so that means I have only 1. And what times 1 equals +2? 2. So I have copper 2 sulfate. And you're done. So that is naming compounds with polyatomic ions.